Hi, I'm Charlie from Inngest, and today we're going to see how to add semantic search to this CRM demo Next.js application. So this CRM application features many things that you will find in CRM. First, you can upload contacts, so you can take a CSV file, and then you have a Kanban board when you can actually rearrange different contacts depending on their qualified sales and other states. So what we're going to do today is see how easy it is to actually add semantic search to our application. So semantic search enables us to do like very vague query and get very precise results. So if I'm looking for customers that are happy, the semantic search is going to be able to identify such customers based on the notes that are like human written notes. If I'm looking for unhappy customers, you know, say I'm gonna get very precise results. So in today's video, we're gonna take a look at this implementation using Vercel Postgres, also known as Neon Postgres, and see how Inngest is going to help us to do it without having to patch all the API routes or server action and make sure that our search is always up to date whenever we are updating the contacts. So before jumping into the code, let's take a look at the concepts that make semantic search possible, such as vectors and embeddings. Semantic search is able to retrieve all the contacts that match a happy query because it's using a different data set underneath to actually perform the search. Regular search that like the one that you have on most applications, do like maybe some typo tolerance, but are only going to retrieve things that actually contain happy because it's doing string comparison behind the scene. A semantic search is working differently. It's relying on vectors, which are a numerical representation of the string that carry some context. And this context is provided by the embeddings mechanism. So what are embeddings? Embeddings is the transformation from a string to a vector. So on the left, you have the string, and on the right, you have a fake example of a vector representation. And so the way to achieve that is the following. What we're going to do is, like in our Next.js application, we're going to take some strings and send them to the OpenAI embedding API, which is going to return us some vectors, which are like array with a lot of float numbers. Then we're going to take those vectors and put them into a vector store, which is a very specific type of column that you can add to your Neon Postgres database if you are pgvector enabled. We'll look into that a bit after. So let's take a look at this vector thing. So the vector is actually not a translation of the ASCII code, of the string. It's actually a model that is specifically trained to add some context to specific words. And these words are like then represented into the vector space, which is a highly dimensional, not a 3D like X, Y, Z, but like thousands of dimension that represent how close the different like provided strings are to each other. So this is like very high level and theoretical. So let's have a great example. So for LLM, the bank, for us, if I say bank, depending on the context of the actual like sentence, it's going to be super easy for me to see if it's like a river bank or like a bank where there is money, If you do strict string representation, it's going to be hard, for LLM to understand that. So what the embeddings, which is like the translation from string to number representation, which are like vectors, is doing is not like a 1-1 translation, is adding a lot of context to make sure that you can have that, for example, like bank, when it's linked to money, is going to be far away in the vector space from like a river bank that is actually linked to maybe fishing, So let's take a look at some like real example on how this is working. So two main use cases that are like pretty famous when it comes to working with embeddings and pouring something is what we're going to do today on the right. It's similarity research. So you end up having this vector space when there is a lot of different like vectors and stuff. And if you want to say, for example, I want to know customers that are happy, the SQL query we're going to write, it's not going to do string comparison trying to find my contacts that are happy written in it in the notes. is going to do like a vector similarity. So I'm going to look at the vector space and see which words are close to each other. So for example, like satisfied is going to be close to happy, and unhappy is going to be close to like complain. So this is a very, very powerful, and vector is actually a very, very performant also at scale way to do this kind of operations. On the left, another use case we're not going to cover today is clustering, which is kind of the reverse, but like similar process of saying, I don't know what I'm looking for, but identify for me the different groups that are formed depending on the different distance, on sensitivity in my vector space. So we could say, for example, that we do clustering on all contacts and say, okay, give me the different type of group of contacts. And maybe it's going to say, okay, there is people in IT, there is people in like, I don't know, like industrial thing. So this is very powerful. And as you can see, like the principle behind it are pretty simple, because technically the only thing we're going to do here is update the schema to add a new column that's going to be a vector column, and do some OpenAI calls to generate embeddings using the OpenAI API. So let's get started now. So back to our Next.js application. So we're not going to build here the application from scratch. Instead, you're going to be able to use the repository available on GitHub. And by cloning this repository, you're going to have everything set up by default. So you're going to have access to the data, to everything. So let me just drive you how to set up the repository real quick. So what you have to do is actually to clone this repository. Then you have the repository. You can install with npm the dependencies. This is already done on my side. Then the next step is going to be to go on Neon. So you're going to go to neon.tech and to create your database. So also Neon, you can create a new project. So you're going to say Next.js, Semantic Search. You create a project, and then you're going to land on this page when you're going to have like all the credentials that you need. So here, what we want is to take this, so you're going to be able to actually copy it, and you're going to be able to paste it in your on.locale. So you have an example, you're going to be able to paste it here. You also have to put the HTTP localhost, this, and you can save this file as .alt.local. Once you have that set up, what you're going to be able to do is to run npx. Okay, this is not this one. npx drizzle kit generate. And this is going to generate everything. This is going to set up, your types. Then you're going to be able to do the same, but migrate. And migrate is going to set up your remote Neon database with the schema and everything. And finally, you can do a push. Then you'll be set up. You can start your application. Once you run all the migrations using Drizzle install dependency, what you can do is actually start the application. And then we're going to land on the application that is empty, that doesn't have any kind of contact. The repo contains data folder with fake data of contacts to import. So what you can do is actually click on Add Contacts, choose File, and select the CRM data. Then you can upload contact. And if you go back here, you're going to see that it works, and we have like all of our contacts here in our content. If we go to the Neon console and refresh, we're going to see the data has been imported. So now you have your application ready and set up locally. So we're going to take a look at how to actually add this semantic search. So how we saw previously, to power semantic search, we need to have like vectors, and to have vectors, we need to have embeddings. So this is what we're going to achieve here, combining Inngest and Neon. So let's go back to our application. The first thing we need to do is to update the schema. So I'm going to update the schema, and I'm going to add an embedding. So looking at the docs, I'm going to look at the docs of Drizzle, and there is a page that's explaining how to actually implement such thing. So I need an embedding. So I'm going to add embedding column. I'm going to accept the suggestion of cursor. And I'm going to add an index for performance reason. So here I'm going to add the index. The index is going to help, the vector search to be even more performant. So here everything is up to date. Okay. So now that we have the changes in the code, what we want is actually to generate a migration. So first, what we're going to do is to run generate. Generate is going to generate for us the migration. So here we saw that we have like a new migration, SQL migration, and there is an extra step that we need to perform. So I've written in the docs of Drizzle, there is an extension, a Postgres SQL extension that we need to enable, which is the vector extension. So by default, Postgres doesn't come with vector support. It's an extension that needs to be enabled. That's the case with most database provider. And Drizzle cannot generate that. So what we're going to do is actually to update manually the migration. Okay. And now that we have everything ready, we're going to migrate. So if I go back to my contacts table, we can see that now we have a new embeddings column. So we are ready, our database is ready. So what we can do now is to actually add ingest. So ingest here is going to be helpful because it's going to help us to centralize the generation of embeddings. So normally the way you would actually do embeddings, like any kind of things in the Next.js application, is by updating the actual root and to add the logic in the root. But there is some limitations to that, which are performance and reliability. So the first one is that, for example, let's say you're going to import like a 1000 contact, then you have to generate the 1000 embedding directly in the API, which is going to be slow, might lead to timeouts. And the second point is like you might reach some rate limiting issue with OpenAI. So what you can do is actually to use, and this is what we're going to do today, the ingest integration with Neon that enables us to react to changes made to the database. So we're going to hook ourselves to any kind of update made to the contacts table to run a workflow that is going to run in our Next.js application. And this workflow is going to generate the embeddings and update the record in database. So let's get to it. First, what I'm going to do is to install Inngest. Yeah. So while this is installing, what I'm going to do in SRC is to add a new folder, ingest folder, and I'm going to generate the client. Not generate, actually, I'm going to write a client. So an ingest client is the following. It's a wrapper that's going to be helpful to actually keep all the information about your current application, enable ingest to identify it, and to link the function that you created to your application. So here we gave a name to our application. And now what we're going to do is to create our workflow. So to create a function, we're going to use our client and we're going to pass 3 arguments. The first one is going to be the name of the function. Then the second one is going to be the event that the function is going to react to. And the third one is going to be the actual code of our function. So when we want the ingest, so the ingest and neon integration gives very specific names. There is like a semantic to follow. All events that are being triggered by the neon integration, starting by db/ and then the name of the DB, and then there is specific verb, like it can be inserted, deleted, updated, this kind of thing. So here we gave a name to a workflow, we have an event listening to, and we have the core of our function. So here what we want to do is to extract some information from the event. And for that, we're going to have to look at the shape of the event. So looking at the docs, we can see that the event have this following shape. So our ingest workflow is going to receive an event with data.new when it's inserted, or data.updated. Here we're going to stick to the new because our application only inserts new contact and does not update them. But we can combine that. So data.new contains one property for each column, and each column is each property is going to have a data property and encoding. So what we want is to extract the property we want to include in our embedding. So the property that we're going to be able to search in. So looking at our schema again, if we look at our schema, the properties that are going to be interesting for us are going to be first name, last name, notes, and company. And the first thing we want to do here is to generate the embedding. So the interesting thing with Inngest is that your workflows are built around steps. And you're going to define multiple steps, and each steps is going to benefit from like retries and throttling configuration, etc. So let me give you an example. Here we're going to generate an embedding. So for that, we're going to do step.run, which enables us to create the steps. So here, I'm going to generate the step, and we're going to take a look at the embedding after. So here we have a first step, and the first step is going to be to generate the embedding. The second one is going to be to update the contact in database, like this. We forgot to actually select the ID, and we have to have a Neon client to access the database. So the interesting thing here is the way Inngest is working. So we have a function, which is a workflow that reacts every time a contact is going to be inserted in the database. It's going to be called with the property that we extract here from the payload. And the first thing we're going to do is generate an embedding. So this first step is going to run. Then we're going to get the results here, and we're going to use this result to save it to database. So the interesting thing with steps is that steps are retrievable in an isolated way. So if the generate embedding is successful, but saving to DB for a random reason is failing, maybe a network issue, then the workflow is going to retry and start again at the second step without running the first one. So this is what makes like Inngest really powerful. It allows you to create like reliable workflows in a very natural way. You don't have to have like very complex API. You just have to wrap your code, and then you make it resilient out of the box. So one thing we have to do here is actually to create an OpenAI client. So for that, we have to install OpenAI. And also in your .app.local, you have to add an OpenAI key. So this is the example, and you have to do it in your app.local. So now you have everything ready, almost. We need to read through the embedding. So now our workflow is almost ready. This workflow is going to run every time a contact is going to be inserted. So one thing we want to do is actually to make sure that if we have thousands of contacts being inserted at one point, we want to distribute them in time to not reach the rate limit of OpenAI. And doing this kind of pretty complex configuration is a one-liner with Inngest. So what you can do is actually to do a throttle, and you're going to put a limit, and we're going to say, okay, we want to do 10 runs, concurrent runs, or 10 runs every minute. So this is going to enable us to update the vectors in a scalable way while enabling to import a large amount of contacts. So now what we need is to make our ingest function available to ingest in the same way that you create API routes, to make them available through the API. So what we're going to do is create a folder called ingest and a new root.ts. So this is a new endpoint that we're going to add to our application to expose our workflows to ingest, because ingest is reaching out to our Next.js application through this API. So to run the local dev server, I have to run the npx ingest -cli space dev command. This is going to download and run the local dev server of Inngest that enables you to run the workflow and get a preview, what's going to happen when deploying your application. So here, if I go to the Inngest dev server URL, I'm going to see the list of my functions. And what I want to do is to trigger this function to see it run and see if the embedding is going to generate. So we're going to use this payload, this data payload, and mimic it, to see how everything's behave. So here I have the data, and I'm going to use it. So this is new. We have ID, so we're going to take an ID, the first contact. We're going to use the same information. So the first one is James Wilson, James. And then I'm going to have, so this is going to be first name. This is going to be last name. We're going to have email. We're going to have company. And we're going to have notes, because those are the fields that we need. Okay. We can ignore that. We can remove this because we don't use it. We can keep that just for sake of being like compliant. And then we're going to copy paste those information. So I have the fake email, which is here. I'm going to have the company, which is taken over. And then I'm going to have the notes that are going to be here. Okay, so now we're going to trigger our workflow. So you get redirected automatically, and then you can see it already ran. And the two steps have been performed. So the first one is generate embedding, and we can see here the actual embedding returned by the step, and then we can see the store embedding that actually updated thing in database. What we're going to do now is actually look into DB to see if things have been updated. And here we can see that yes, all contact has been updated. So what we're going to do now is to create a workflow that's going to help us to migrate all the existing records just for dev purposes. So here we have a generate all embeddings function. This function is going to take all the records in the contacts table, apply some concurrency, otherwise we're going to reach the rate limit of OpenAI on the embeddings API here. And the first step is going to fetch all the contacts, and then we're going to have parallel steps using promise.all to process all the contacts in parallel. So this is very powerful. This is how you actually achieve parallelism with Inngest, is just by using promise.all. Now I need to add this new function to the root to make it available for Inngest to discover. So if I go back to my dev server, I'm going to see this function that's going to happen here. And if I invoke it, I don't need to pass any data. This one doesn't need any kind of data. We're going to see it run. And see, all the contacts are being like performed in parallel, but also while actually matching the concurrency of 10 contacts in parallel maximum. So this is actually pretty fast, but it also matches the rate limiting of OpenAI. So everything has been performed. You can see like 50 processed. You can see the result and everything. So now we can go back to our Neon console and look at the data a bit. So here we can see that every contact now has an embedding. So we are in good position to add the Semantic Search UI and wrap up our new feature. So to focus on the backend side of things, we're going to switch to a new branch that already have the search page implemented. So this branch is called search page. So if I go back to the application now, I have a search page. And I'm going to be able to perform some query, like either like any kind of upsell opportunity, and it's going to find all the contacts that have kind of like upsell intent. So this is using the embeddings that we just generated using like the generate all embeddings. And every time we're going to add a new contact, the embeddings are going to be updated for the new contacts. So let's have a look at the page. So the search page is pretty basic. It's doing like a fetch, to call like a root. And the root is what's interesting for us. And this is what we're going to take a look. So we have a new root here. It's called like the search root. And what we're going to do here is do a search query. So if you remember, there is many things we can do with a vector database, and using vectors, there is clustering and there is similarity search, which is why over the semantic search. So what we're gonna do is take the query, for example, upsell, create an embedding of this word, and do a SQL query to try to get all the contacts that are close to this search vector. This is the way it's called. So let's take a look at the implementation. So first we need an OpenAI client and a Neon client. So OpenAI to generate an embedding of the search query we are making, a Neon client to actually perform the SQL query. Then we're going to take the query parameter and we're going to create an embedding. So exactly the same logic that we used in our workflow to generate each contact embedding. So this translates our query like happy, unhappy, etc. into an actual vector. So this is going to be an array of number. And here we're going to do a query. So like we said, like the vector thing is actually a type of column, type of data type that is an extension to PostgreSQL. So we're going to be able to do like some kind of vector operation. And here, this is the way you actually do some vector operation that is called similarity. So here, and then what we're going to do is order the result by the best similarity. So if you want to learn more about this operator, you can go actually to the Neon documentation. So if you go in the Neon documentation in the AI and embeddings, you're going to find some explanation on how to query vectors, because this is specific operators to the pgvector Postgres extension. So here we can see that we can do like nearest neighborhood. We can do this kind of thing. And actually what we're doing here is the nearest neighborhood that we also call like the similarity. So it's going to take the distance between two vectors. What we want is actually to get the distance, and the shorter the distance, the better similarity that we have. So this is exactly what we do here. So once we get those results, we're going to get the result and a score, and the score is going to be the inverse distance, from 0 to 1. And this is what we got here in the UI. So if I do upsell, we're going to see the score, and this is going to be basically the distance between the vector that represent upsell and the vector that represent this contact. That's it for today. I hope you enjoyed this video, and as you can see, semantic search is very powerful, and this is a very basic implementation. You can go and use this template, to actually tweak and play with the different like operators you can use to make it more powerful and change the embeddings that are actually stored in the context to improve the relevance. So as we saw today, using Inngest in combination of Neon makes it super easy to add embeddings to any kind of data that you have in your existing database to perform like search, but also to perform other things such as RAG and all those things you can do with LLM. You'll find the instruction to deploy this application in production using Neon in Inngest in the README of the repo. And we have more and more video coming in this channel featuring how to use Inngest for AI, but also a lot of other use cases with Next.js. So please remind to subscribe to be notified about the next video.